Let's do some problems where we practice what we learned. In this first problem, I have this triangle here. I want to fill in all the missing sides and angles. I'm going to start with the angle because that's easiest. If this one's 30, this is going to be our 60. 30, 60, 90. Now I use my patterns. So if you need to reference back to your pattern that we did on the other page, you're welcome to. I am starting with the long side, not the hypotenuse, the long side. So let's start by going from this long side to this short side. If I'm going from longer to shorter, then that means I'm dividing because that makes it smaller. And I just have to remember what I'm dividing by. If I'm going from this one to this one, the number we were dividing by was √3. That was our pattern. So that means this side will be 7 over √3. Because I'm getting smaller, so I'm dividing, and it's by √3. Now let's get from this small side to the hypotenuse. If you don't remember this pattern, think of our 60, 60, 60 equilateral triangle. If I make that 60, 60, 60 equilateral triangle, it's a lot easier to see. This one is going to be double this one. So I need to take this 7 over √3 and times it by 2. Now, keep in mind that means times by 2 over 1. So we're really only multiplying the numerator by 2. You don't want to multiply the top and bottom by 2 because that would be multiplying by 2 over 2. So if I take this, multiply by 2 over 1, that gives me 14 over √3. And I have solved for all three sides and all angles of this triangle. I'm done. That's it. So let's look at example 4. Example 4, it doesn't give us a picture. We need to draw a picture. So it says we have a right triangle. One of the angles is 60. So I'm going to draw mine this way this time. And I want one of the angles to be 60. Which we know means the other angle will be 30. Now you'll notice I was really specific in how I drew this triangle. The bigger side should be across from the bigger angle. The smaller side should be across from the smaller angle. Make sure you're doing that or else you're going to mess up your patterns. Make sure you're visualizing how long the sides are in relation to each other. Now we also know the hypotenuse of this triangle is 20, and we want to solve for everything that's missing. So I want you to use your 30, 60, 90 patterns this time. Pause the video. If we know the hypotenuse is 20, what will the other two sides be? Pause the video, try that out, and then come back to check your work. First one I like to think of is imagine your 60, 60, 60. There's our equilateral triangle. So if this side is 20, then I know this short side has got to be 10, half of that. And then to get to the other side, because I'm going from something smaller to something bigger, I'm multiplying, and we multiply by √3. And there we go. We're all done. So with that in mind, let's do one story problem like this. We have, it says, the angle of inclination. Let's figure out what that is first. Angle of inclination is the angle from a flat horizontal base up to the top of an object. So we have a flat horizontal base, and this is the angle up to the top of some object. And it says the angle of inclination from a point on the ground 30 feet away from the base of a water tower to the top of the water tower is 60. So this angle of inclination up to the top of this water tower is going to be 60 degrees. So I know that is my 60. Now I need to draw this little water tower here. Practice my wonderful art skills. Water. And we know that this is going to be a right angle with the water tower, which means this other angle is going to be 30 And you'll notice once again, I tried to make the shorter side across from the smaller angle, the longer side across from the bigger angle, so I could draw them proportionally. Now we also know that this is a point 30 feet from the base of the tower. So that is 30 feet. And we want to figure out how tall is the tower. What is the height of this water tower? It says to the nearest foot. So this is a 30, 60, 90. Once again, you can practice your patterns. So what I want you to do is pause the video, and I actually want you to put in this side and this side just to practice your patterns. And then whatever this is, if you need to, put it in your calculator so you can round to the nearest foot of how tall the water tower is. Pause the video, try that out, and then come back. Let's see how you did. I always think of my equilateral first. There's my 60, 60, 60. So if this side is 30, that means this long hypotenuse is 60. It's double that. Then if I want to find this last side, I go from the short side to the long side. So since I'm making it bigger, I'm multiplying. So 30 times root 3 is the height of the tower, which I put into my calculator and got to be about 52 feet tall. Now, let's try example 6, and we'll do this the last one for this video. Then we'll have one more we do. This one is a really good one to do because this is not a special right triangle. Notice that our angle is 75. So this is not a special right triangle. It's not our 45, 45, 90 or our 30, 60, 90, which means this is going to be a calculator problem, which is a good one to practice. So let's see what's going on here. How long must a ladder be to reach a windowsill that is 50 feet above the ground? Here's my windowsill. If the ladder is resting against the building at an angle of 75 degrees with the ground. So we have a ladder that is resting against a building. So let's do our ground here. And the angle is 75 degrees with the ground. So we want to go 75 degrees up from the ground up to the top of our windowsill. Here's our ladder. And we want 75 degrees with the ground. Now, we know that if this is 75, this is going to be 15. Notice, or if you remember, all angles of a triangle need to add to 180. So we could do 180 minus our 90 right triangle minus 75, and that gives us 15 up here. So we know this has a 75 degree angle with the ground. We also know that the windowsill is 50 feet above the ground. And we want to solve for how long will the ladder be? What is the length of this ladder? So let's start by doing some trig stuff. I want to notice first off the sides that I'm focusing on in this problem. Notice two sides have things written, one does not. That means the sides I'm focusing on are this one, which is my hypotenuse across from the right angle, and I also have this side that I'm focusing on, which is across from the angle I'm given, so that is going to be opposite. Here's the angle the problem gave me, so that means that's the angle I'm focusing on, so that means this side's opposite, that's adjacent. However, for this problem, I don't really care about the adjacent side because I don't have any information about it. So I look at what sides I've been given, what sides I'm focusing on. I am focusing on O and H. So if I'm focusing on O and H, what trig function is that focusing on? So I think SOHCAHTOA, the one that uses O and H, is sine. So I'm going to write this out. Sine of the angle I'm focusing on, there's my 75 degrees, equals the O side, which is 50, over the H side, which is the L I'm solving for. And I just need to solve this equation. So times both sides by L to get L out of the denominator. So I get L of 75 equals 50. Divide both sides by sine of 75 in order to get L alone. So I get L equals 50 over sine of 75, which you can then just type into your calculator to get 51.76 feet. So this ladder needs to be about 52 feet tall, at least, to get up to this windowsill. So that is some application problems using the trig that we've learned so far. We have one more problem to do. It is a really awesome problem because it combines everything we've learned about so far this lesson. So we'll save that for the next video.